Okay, this is going to be just a quick review of what we've been going over in class. I just wanted to reiterate the fact that the protons determine the element. So if I add protons to my atom, this will distinguish one atom from the other. So right now, if I have 2 protons, that's going to be helium. For this particular atom, we need about 2 more neutrons to make a total mass of 4. So you can notice that my mass counter has changed to 4. My protons are 2 and my neutrons are 2. Now you are going to need electrons as well, otherwise this wouldn't be a complete atom. To be neutrally charged, you would need 2 electrons. And I know I'm neutrally charged because my negative electrons equal my positive protons. So look at my count. 2 electrons, 2 protons, 2 neutrons. My mass is 4 because that adds my neutrons plus my protons. The electrons, remember, are not considered in the atomic mass because they're too small to be counted. My atomic number is 2 because that is my proton count, and that determines the element. So this is helium. I don't have a charge right now because I have equal amounts of negatives to positives. But if I go ahead and add an electron to the next level up, you notice that my charge has changed to -1. That's because I have one more negative than positive. Let's go ahead and reset this, and we're going to make a different atom. If we, let's say we made the isotope, let's see, let's go ahead and make carbon-12. That's a pretty common isotope. The word isotope means that it's just a variation of an atom. Every element is an isotope, but some atoms have more isotopes than others, meaning some atoms have multiple variations of themselves compared to others. Carbon is a perfect example of this. There are different isotopes of carbon. For instance, carbon-11, carbon-12, carbon-13, carbon-14. What that means, carbon has 6 protons. So if we add 6 protons to our nucleus, like this, and we want to mix our protons around with our neutrons, because this one doesn't want to stay, because our protons will naturally want to repel. So we want to mix these up so our protons won't repel each other. So right now we're at 4 neutrons, now we're at 5 and 6. So you see we should have kind of mixed it up a little bit better. You see our proton counts at 6 and our neutron counts at 6 to give us a total atomic mass of 12. Okay, our atomic number is 6 because remember that determines how many protons are in our atom. 6 is always going to be carbon. That's its unique number. The charge right now is +6, and the reason why it says that is because I haven't added any electrons. So let's go ahead and make it neutrally charged, and to make it neutrally charged, I need the exact same number of electrons compared to protons. So I'm going to go ahead and I'm going to add 6. And I'm doing this in a certain way. This is kind of how the electrons fill their orbital ring. They kind of do, you know, each of the corners, and then they start pairing up. So right now I have 6 electrons, and you notice down here on the bottom, my charge has changed to 0 because my positives have equaled my negatives. I am not an ion. Ions are charged atoms. In order to be an ion, you would have to, the element carbon would have to gain an electron or lose an electron. If I gain an electron, and now notice I have 7, compared to my proton number, which is 6, you can see that my total charge is now -1 because I have one more negative than positive. Okay, that's called an ion. I'm going to go back to the original 6 and 6. So this is just going to be called a neutrally charged atom because my pluses are equaling my minuses. This is a type of isotope, and the way that we're going to write this isotope's name is we're going to say the symbol, which is carbon, C, hyphen, I'm going to put a little hyphen, the mass number, which is 12. So this is carbon-12. If I wanted to make a different isotope of carbon, I would either add or take away a neutron. In this case, I'm just going to add a neutron, and this should change I just added a neutron to here. You see my atomic mass went up to 13 because I have 7 neutrons and 6 protons. 6 plus 7 is 13. My total atomic mass is 13, so my isotope name is C13. Another one that you use for radioactive dating when you're doing geology is carbon-14. Carbon-14 is an isotope of carbon, and it's 8 neutrons and 6 protons. Notice that my protons never changed the count. All I did was add more neutrons or I took them away. These are all variations of carbon because they all have the proton number 6, but they're either more massive by adding neutrons or they can be less massive by taking away neutrons. So if I took away 3 neutrons, you can see now I'm carbon 11 because my mass is 11. I have 5 neutrons and 6 protons. Notice my charge stays the same because I didn't mess around with my electrons. My pluses and my minuses are still equal. And this is kind of what we had been doing in class. I just wanted to repeat it. Thanks for listening, and I'll see you in class.